Okay, now let's look at the ANOVA table one more time and try to understand the interrelationship among the numbers that we have. Suppose if we have a problem with 65 observations, all right, and then we have number of variables is 4, okay, and let's assume that one of these 4 variables there is a qualitative variable. One of these is qualitative or categorical variable with 4 levels. Okay. Then let's assume that the mean square regression is 54 and sum of squares residual is 525. Okay. Now given this, we want to populate the rest of the cells in ANOVA. So how are we going to do that? Okay. First, let's start with the number of variables. Okay. So how many variables will we have in the regression? Okay. So there is 4. Out of that 4, 1 is a categorical qualitative variable. So we have only 3 regular variables. And then that one categorical variable will come in as dummy variable, a set of dummy variables. How many dummy variables? So that one categorical variable has 4 levels. So that means we will have 3 dummy variables. So the total number of variables will have independent variables. That is, total number of x's that we will have is 6. So n minus k minus 1, that's the degrees of freedom for residual, is that. So now we are ready to set up the degrees of freedoms. So for regression it will be k. For residual it is n minus k minus 1, and for total is n minus 1. All right. So now we can figure out what these will be. So this is sum of squares divided by 6 is what is 54, right? Mean square is sum of squares divided by degrees of freedom. So with mean square and degrees of freedom known, so if you take mean square and multiply that by degrees of freedom, so you will get the sum of squares for regression. So which means your total sum of squares will be that. Okay. So now mean square error is sum of squares divided by that degrees of freedom. So which means f is going to be MSR divided by MSE, and the p-value is f dot dis dot rt of the f and the 2 degrees of freedoms. Okay, let's make that into a percentage. Okay. So r squared then is regression sum of squares divided by the total sum of squares. Okay. So doing problems like this help you understanding exactly what is going on inside the ANOVA.